In chapter 27, we are talking about inference for slope. So confidence intervals and hypothesis tests about measurements of slope, which means we're going back and doing a lot of stuff involving stuff we did in chapter 7, 8, and 9, scatter plots. So with that being said, we're going to do this worksheet together first, the front side. So remember all the stuff we did way back in Unit 2, because it all goes together. You have to know this stuff to answer most of the free response questions. Then today we'll spend some time talking about confidence intervals. If we have time, we'll talk about hypothesis tests, but I doubt that we'll get there. Okay? So we're going to start with this worksheet. We're going to do it together. New state requirements force students to take a high-stakes math test in order to graduate from high school. Faced with such a pressure-laden situation, many students become very nervous, which may interfere with their ability to perform well. Concerned about test anxiety, a researcher enlists 24 student volunteers for a study. A psychologist interviews them before the math test, assessing their anxiety levels on a scale from 1 to 10. The table shows the anxiety levels and the exam scores. Enter the data in your calculator and make a scatter plot. So, I already have the data in my calculator, but if you want to follow along, please enter the data in your calculator. Now make sure you're typing in anxiety level and math test, because student number doesn't count. That's not one of our variables. That's categorical, I guess, if you want to think about it that way. Yes. Once it is in your list, you can make a scatter plot. So, stat plot, we want to look at L1 versus L2. Scatter plot's the very first choice on the 84. Always hit zoom 9 if you're looking at a graph from statistics. All right. So, it says, does there appear to be an association between anxiety level and test score? Describe what you see in the scatter plot. There are 3 things that you're supposed to talk about when you talk about what a scatter plot looks like. I know, make you think way back, but anyone remember any of the 3 things you're supposed to talk about when you're looking at a scatter plot? Shape is not really one of them. It's not what we call it because we don't have an actual shape like a histogram. It's something like that. So linear is what kind of, what do we call that though? Because they're not all linear. We said the form, right? So form is one of them. When you look at the form, what are the 2? If you can name something about the scatter plot, we can go back and name what it's called. But so look at the form. What else do we look for? Positive, negative, so that's the direction. So form, direction. There's one more thing. What else do we just want to say about the scatter plot? Direction, form, and strength. Yes, so direction, form, and strength. So if we're going to describe this scatter plot, what would you say about it? Negative. If it's negative, that means it has a form. Min said it was linear earlier, right? It's not an awesome straight line, but if we can see there's a direction, then we're going to assume that it's linear. And then what do we say about strength here, you think? It's weak. Now it's not super weak because again we can still see a direction, right? So we would say for this first question, looking at our scatter plot, there appears to be a weak negative linear association between anxiety level and test score. It depends on what the questions ask you, and this one is saying that they think that anxiety affects test score. So anxiety should be X, yes. All right, any other questions about just describing? Again, we've done all this. This is just a jog of memory today. Okay? So the first part of this, you have seen it all, but we haven't looked at it in a long time. So if you have questions, please ask me because it's stuff we haven't seen in a long time. That's okay. So any other questions about describing the scatter plot? Direction, form, and strength. All right. The number 3 says find the correlation R. Be careful. On the last test, it wasn't a lot of people, but a few people used the word correlation when they were talking about their paired data. I understand that the word correlation is something we use in the English language a lot, and I get that. But remember, in statistics, correlation is a number, and so you can't use correlation in like other random places, okay, when you're talking about stuff. Correlation is distinctly a number, R. So you can find that number in your calculator. You will go to Stat, Calc, and you're going to 8. You want your X list to be L1 as long as you put anxiety in L1, Y list to be L2, and we can leave everything else blank. We're just doing linear regression, A plus BX. Sorry, I forget you have your inside. There are 2 linear regressions in your calculator. There's an A plus BX and an AX plus B. They give you the same numbers, just in statistics, in like the AP class, they would prefer you to have this format, so that's what we use. Calc 8. And then list 1, list 2. Nope. Do you have 3 numbers instead of 4? Or instead of 5? Yeah, so you have 3 lines instead of 5. Okay. Anyone else have 3 lines instead of 5? All right. So if you have 3 lines instead of 5, not a big deal. That means that there's some stuff not turned on in your calculator in the background, and that's okay. It's in 2 different places. I remember. Apparently, it's under mode, supposedly, but I don't ever know. I just always go to second catalog, and I hit D. And I scroll down to diagnostic on second 0. Sorry, second 0 is catalog. You can just type a D in and then scroll. Diagnostic on and hit enter. It's also under mode, I think. Do the mode menu. Yeah, stat diagnostics need to be on. Either place. All right, so now if you go back to stat calc 8, you should see all of the lines that I have. Okay. Okay, so correlation is R. So that is negative 0.525. It should be negative because we said there's a negative association. And then it says what does the correlation indicate? So what does correlation mean? What does correlation talk about? Strength. So correlation is going to be your strength measurement. So we can say, again, the closer it is to -1 or 1, the stronger it is. So closer to 0 it is, the weaker it is. So there's no cutoffs. There's no set, this means it's strong, this means it's weak, etc. It's totally up to you. So -5.25, that's up to you to say if it's weak or moderately strong or whatever you want to say. All right, but so what does the correlation indicate? Indicates that there's a, whatever you're going to call that, however strong, association between anxiety level and test score. So do you think it's moderately strong? Do you think it's weak? Whatever. Which just indicates the strength of the association between your variables. It's arbitrary because there's not a cutoff. So you can't say it's super strong. Obviously, -5.25 is not super strong. But you just depending on what you feel like -5.25 is. Is that weak or is that moderately strong? Up to you. Any questions about correlation? Everyone good on their calculators? Things I still need to fix. Nope, that's fine. We're going to do that in a second. All right, number 4 says interpret r squared in this context. So r squared tells us two things. First of all, r squared is actually just r squared, so it's a correlation squared. R squared is a percentage, so r squared is 27.6% in this case. And r squared tells you two things. It tells you how well the model fits, which is not asking us right now. And so what I mean by that is, if the correlation was 1, then 1 squared is 1. So r squared would be 100, right? That means all of your data is a straight line, and so the model fits every single data point, and so it fits really well. R squared of 27.6 means if you go back and look at the scatter plot and you draw the line in it, it doesn't fit so awesome because remember our data was pretty spread apart, okay? So maybe not be the best fit for the data. That's all that means, okay? What they want us to do here, though, is interpret what it means. So this is that sentence that you haven't heard in a long time, so I'm going to write it. So 27.6% of the variation in your y variable, so in this case in math test score, is accounted for by, you can say the model, or you can say the x variable. So by anxiety level. You have to say this or this. That sentence, I can almost with 100% certainty guarantee it's going to come up somewhere on the AP exam. So again, that goes back to how well the model fits. How much of that variation is it taking into account when it creates that linear equation? But so that, if they ask you how the model fits, you can give them a percentage. If they ask you to interpret, this is what they mean. This sentence. Questions so far? Just all ringing a bell, jogging memory? All right. Then 5 says to create the linear model. So the linear model is the equation. Remember, your equations are in the form of y hat equals the y-intercept plus the slope times x. They're always in that format every time. Why is it y hat? What does the hat mean? So we've been using hat for other things, right? P hat was our sample proportion. Y hat here means, hat really just means estimate, right? So y hat means if we put a value in for x, we're not getting an exact data point. We're getting a prediction from the equation. So it's going to be our predicted y. Okay? Can I erase what I have so far so I have room to write this equation? Okay. So if you go back to your calculator, it tells you the equation. It tells you at the very top, y equals a plus bx. So a is your y-intercept, and b is your slope. Whatever's written next to the x has to be the slope, right? We've learned that in algebra. The only other thing to remember is when you write equations and statistics, you write them in context. So you don't write y and x, you write actually what the variables are. Okay, so we have math test score hat equals, our y-intercept is 91.66 minus our slope, because it's negative, negative 4.49 times anxiety level. Does that make sense? Okay. So number 6 says, is this linear model appropriate? Then it actually helps you out. If it's ever asking, is linear model appropriate, you always look at the residuals plot. It tells you that in the second part of this question. It says, create and discuss the residuals plot. But normally it won't. It just says, is linear model appropriate? And you know you're supposed to look at the residuals. If you do StatCalc 8 in your calculator, so you do a regression analysis in your calculator, it automatically fills all the residuals in, and it already has it stored in your calculator. Okay? So you don't even have to go check. It's in your list, but you don't even go check. If it's not in your list, it's still in your calculator, so it's there. Okay? So we need to look at a residuals plot. So you go back to your scatter plot, and this time you make a plot between your variable and your residual. So you want to type in resid. And again, zoom 9. If you hit second alpha, it turns into alpha lock so that you don't have to go back and forth. I know, they're all over the place. List 1, just your x variable. Yeah. So what were you supposed to see in a residuals plot? Yeah, you want to see nothing, right? You want to see just randomness. You don't want to see any pattern. You don't want to see curves. If there's curves and stuff, that means that there's something going on in our scatter plot that we didn't originally see ourselves. Okay? We want to see nada. Okay? So it says, is linear model appropriate? So is the model appropriate? Yes or no? Yes. Because the residuals show no distinct pattern. Everyone go with that? Okay. We'll go back to the calculator again in a second. Number 7 says interpret the slope of the line in this context. So, and number 8 says interpret the y-intercept in the context. So we're going to have to actually write it all out. Here's how you remember it. It's not hard to remember. It's like a sentence you have to memorize if you know what slope is. Slope has always been in algebra forever and ever, rise over run. So it's the change in y over the change in x, right? It has always been that since we learned about slope, okay? So if we're talking about interpreting the slope in this context, we're always talking about for a change in x of 1. So I know the slope of this line is negative 4.49. If I make that into a fraction, it's negative 4.49 over 1, right? So that's a change of 1. So just write that out in sentence form. So for every increase of 1 point in anxiety level, because that was our x variable, right? So if your anxiety level increases by a point, I expect a decrease of 4.49 points on the math test. Does that make sense? It's just slope. It's not really a sentence to memorize as long as you know it's slope. Every change in 1x, this is how y changes. I expect a decrease. When I see free responses about this stuff, this is what they do. They ask you, they give you a computer output. We're going to talk about that in a second. But they give you a computer output. They expect you to write the equation in the line. They expect you to interpret the slope. They expect you to interpret the y-intercept. And then they expect you to do a hypothesis test or confidence interval based off of the computer output. Okay? Any questions on that? For the y-intercept, since the beginning of time, y-intercept is always when x equals 0. Right? Since you've ever taken math, that's always been true. So again, there's no sentence template to memorize or anything as long as you know that the y-intercept is when x equals 0. So for an anxiety level of 0, which you can't get because of scale of 1 to 10, but if you had 0 anxiety, I expect a math test score of 91.66. Do you understand where the sentences are coming from? Because if you understand that, it's less to memorize. All right. The number 9 says, does this prove that anxiety interferes with student performance? Jacob's right. No. The word prove is not a good one. Remember, we said way back in the section that correlation does not necessarily mean causation, right? So we can say, if you're trying to write a sentence or anything, you can say that there's an association between anxiety level and math test score, but we can't prove that that anxiety level causes poor math scores, right? We can't say that. We just know that they're associated. You never, there could be some lurking variable. Maybe they take the test in a super scary scenario where they're like, I don't know, have super crazy time constraints and that kind of thing as well, right? So there are other variables we need to consider. We can't just prove it based on this one. Any questions about any of this? hold on to this worksheet, don't put it away. We're going to come back to the back. We can't do the back right now currently because the back is asking you about hypothesis tests and confidence intervals, which I haven't taught you about yet. Okay? But we're going to use that in a second, so we'll come back to that. But I wanted to remind you of all these other things. Okay? All right. In the packet I handed you, then. These are from the Saturday study sessions back when we were part of that AP grant thing. I will give you one of these for every single unit for your review because they have everything all nice and neat and tidied up and explained. Okay? I'm just going to pick and choose pieces of it today for what we need. Chapter 27, they want you to do confidence intervals and hypothesis tests, but they want you to do them completely based on a computer output. Right? I have never seen an example where you don't have a computer output. All right? If you were given without a computer output, then every single person that took the AP exam would probably not do well on it because I don't know anyone that teaches it that way because it's not shown up on the AP exam. So there are formulas and stuff on the formula sheet, but I'm not going to go over them because I've never seen a need for you to have to use them. All right? If you go back to all of the old free response questions, that's not something you have to do. Okay? So, we're doing a confidence interval. Okay? We're always doing all this stuff based on the regression equation. We're doing inference about the line. So here is the true regression line based on the population. We always come up with regression lines based on samples, though. That's what we do. Okay, so we're going to make confidence intervals about slope because we don't know what the true population would be, like how that would really be. We just know what happened in our sample. Okay, so it's still the same idea. All right, and we'll come back to a bunch of this in a second. But we're going to do some stuff with confidence intervals to make sure. So, if you're looking at the very bottom of this, if you're going to do a confidence interval, you always state the conditions and you name the interval, right? So we'll look at the conditions. The interval it's just called a T interval for slope. That's what we're doing. We're doing confidence intervals for slope. That's the name. T interval for slope. You don't make up anything fancy. Your conditions are going to be a little bit different here. And I'm actually going to use that worksheet, the back of that worksheet, to show you what it means by what it's asking you about. Okay? Your conditions for inference for slope are way different from the ones we've done before because we're now like this whole different realm. All right? We're talking about scatter plots and lines, which is not anything to do with the samples we had before. Okay? So, your conditions spell out line. I can change 4 to be E. I can explain how that would be. But they spell out line if it helps you remember because it's about linear equation. So the first one says the linear model must be appropriate. You have to look at two things. Is the scatter plot linear? And does the residual plot have no pattern? So if you go and look at this example on the other worksheet, it's about average monthly temperature and electrical usage. Well, you can see they give you up here a scatter plot. So is this scatter plot linear? Yes. They give you a residuals plot. Is there any pattern in the residuals plot? No. So far, our first condition is fine. Okay? So that's what it means. You're going to look at a scatter plot to make sure it's actually linear. Look at a residuals plot to make sure there's no pattern. Again, almost all the time, they're either going to say on the test, on the AP exam, they'll say the conditions are met, or they're going to give you all of the graphs. Okay? All right. Next one. Independence. Are all of your data points going to be independent? That's what it's asking. So if you're talking about the example on the front we just did with anxiety level and math test score, are all those students independent of each other? Hopefully. If not, random sampling or random assignment, that's fine too, right? So independence or randomness needs to be checked somehow. in the question. Questions about that condition? All right, the next one is normality. Now here's where it gets a little wonky. It wants you to take the residuals and plot the residuals as a histogram and look at the distribution of residuals to make sure it's normal. So again, going back and looking at that worksheet, the last plot they give you is a histogram of the residuals. Is the histogram of the residuals roughly unimodal and symmetric? Definitely unimodal. Symmetric is a little weird, but it's not crazy skewed to one side, so I'm probably going to just go with it, right? So that's what it's asking about, histogram of the residuals. And then the last one says it wants the standard deviation of y values to be the same for every value of x. So check the residual plot to be sure that the spread of the residuals is approximately uniform. So going back to the residuals plot, again, we already said there was no pattern, but we want the spread to be about even. We want to have some points above and some points below, all right? I always remember as E, I just say like equal spread, okay? We want the spread of the residuals to be equal. Those are your conditions. Those 4 conditions make sense. They're on this piece of paper for your reference for now. So if you do an interval, we name the interval, we do the conditions, then we do the mechanics. We've had the same idea for confidence intervals since the beginning. You have your statistic, plus or minus your critical value, times the standard deviation of the statistic. In this case, we're doing inference about slope. So your statistic, this is B sub 1, is slope. Plus or minus, we're doing a t critical value with n minus 2 degrees of freedom. Make sure you realize that. It's n minus 2. The rest of them we've done have been n minus 1. Times the standard deviation of the statistic. So this is the standard error that's being estimated above the slope. You're not going to have to calculate the slope or the standard error. It's going to be given to you. We should all know how to calculate a critical value. How am I going to calculate a t critical value? What am I going to use? How am I going to calculate a t critical value? How do I find that? What function do I use? Let's find a p-value. Inverse t. Every time you're doing a confidence interval, you're using inverse something to find that critical value. Okay? We should be able to do this. In a second, we're doing an example. We should be able to do this. It shouldn't be a problem. And then 4 is interpret the confidence interval. Some of you guys still won't give me a conclusion. You're at the interval and you stop. You got to write down what that means. And we can talk about what that looks like in a second when we do the example. All right, question. All right, I'm going to do my one example for confidence intervals today, and then we'll do hypothesis tests and stuff tomorrow. On the next page of this packet, so the back of this page, there's an example. As part of a class project at a large university, Amber selected a random sample of 12 students in her major field of study. All students in the sample were asked to report their numbers of hours spent studying for the final exam and their score on the final exam. So that means we have X variable, study hours, Y variable, final exam score, right? Yeah. A regression analysis on the data produced the following partial computer output. Assume all conditions for inference have been met. Okay? Yeah? I'm going to skip some questions, but so on the next page, we're going to do D, where it says find a 95% confidence interval for slope. Okay? So, we've seen these computer outputs before. We did them back in Unit 2. There are 2 lines to your computer output. All right? One of them says constant. One of them says study hours. One of those represents the y-intercept. One of those represents the slope. Which row, constant or study hours, represents slope? Which line? Constant or study hours, which one has the slope? Study hours. Constant means that's going to be where the y-intercept is. Right? We looked at them in Unit 2, and we just looked at this part. We ignored everything else, right? We were like, the rest of that doesn't matter. This was the y-intercept, and this was the slope, right? It's the number that comes before study hours in the equation. So because of that, the confidence intervals we're doing for this are only for slope. We only need to look at this line. Like this line will not help us write the confidence interval. Are we okay with that? Yeah? Okay, so remember we're going to have slope plus or minus t critical value n minus 2 times the standard error of the slope. So from this table, I know I've marked on it. From the table, what is the slope? 2.697. We'll come back to the critical value in a second. What is the standard error of the slope? 0.745. Right? This is what they're gonna look like. These computer outputs on the AP exam and stuff, that's what they're gonna look like. They don't have the bubbles, but they're gonna say coefficient, standard error. You should know that you're looking for the one with a variable if you're doing slope. T and P, those are going to be for your T statistic and P value. We'll use those for the hypothesis test. All right. So this T is not your critical value for your confidence interval. Do not use that. Okay. How do I calculate a T critical value for 95% confidence? Inverse T. We want to be 95% confident, so that's 0.025, right? We have n minus 2 degrees of freedom. If we look back you scroll up to the problem, it says there was 12 people sampled. So what's our degrees of freedom? 10. So we get 2.23. Everyone's still with me? So we're going to find that interval really fast. .23 times 0.745 is 1.66, so 2.697 minus that, 2.697 plus that. I get an interval of 1.04 to 4.36. So now I'm in the mechanics. Again, the mechanics for this way every time you should just be able to look at the table and pick out the stuff. All right? Now, go to the mechanics. We have to write a conclusion. We're doing a confidence interval. When you do a confidence interval, you're always trying to trap the true parameter. So in this case, our statistic is B sub 1, which is slope. So that's from our sample data. So I'm trying to trap the actual slope. Okay? And so because of that, we need to think about what slope means in context here. All right? So before I even write this actual conclusion out, if X was study hours and Y was final exam score, then if I was going to write about the slope, I would say for every 1 study hour, our exam score should increase by blah, 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 right? That's how you write your conclusions here. I am 95% confident that as I increase my study time by 1 hour, I can increase my final exam score by 1.04 to 4.36 points. You write it in terms of slope. Because x increases by 1, my y should increase by my interval. Does that make sense? Because we're talking about slope. That's a little bit different than what we've been doing. You could probably get away with saying 95% confidence the true population would have a slope, a linear regression with a slope of, but that sounds funky. This makes more sense in context. Any questions about that? Just for seeing one done. Where I got anything, the numbers from, how I got the conclusion, what the conditions mean.